Is there any questions? Any issues that you want to raise?
Madame, on n'entend pas bien. On n'entend pas bien.
It's a bit low, the voice. It's a bit low.
Can't hear.
Et maintenant?
Non, toujours.
It's a bit low.
No.
Est-ce que là c'est mieux?
Yes.
Yes, it is
Yes,
good.
now I'm not using the headset, but the only problem is that if there is background noise. So let's try it this way without the headset. So see a background noise, then you see. Can you just, I'll just try again once more, just to see.
It's a bit low.
No,
Can't
low.
hear you properly.
We can't hear you.
Okay, so let me just try without. Là, c'est bien mieux.
Oui.
It's better now.
It's
So I
better
just-
now.
Okay, so I put the headset usually, especially for lectures, because sometimes I have lots of background noise around. So I just hope that it's not going to disturb us. Just trying to find the right angle. Okay, so the topic for today, we are going to start with the second lecture. So in the first lecture, we did a brief of what is a program, programming history and all that. So basically now today we are going to move more into this direction. But of course, we have already started working on our programs, and that was during the lab session. So I will be doing recording today, and when I do recording, I will be switching my camera off. But before I start with the lecture itself, is there anything which is any issues that you want to raise? Anyone? Any issues you want to raise before I start up? Sorry, there are a couple of chats I did not check. Good morning, good morning, good morning, good morning. Okay. So yes, so I forgot to say, so we have a couple of students who are new to this class because they joined in late. As you are aware, there were late registration from UM. So welcome students who just joined in today. If you are not in the group mail, I have already forwarded you the email with regards to our online sessions. If you're missing out anything, you can reach out to me or to the class rep. Class rep, if you can just add in your contact details in the chat room so that the newcomers can contact you. So we have how many class rep here? 1, 2?
1.
1. Okay, so if you can add that. For newcomers, yes, I did not introduce myself. So I am Zareen Kadir Saib, and I will be your tutor for this module, Computer Basics of Programming. The title is long, Software Design Fundamentals of Programming, but basically what this all is about the foundations of programming. So we are not, as I said last time, we are not expecting students to already have a programming background before this module. So there are students who have been doing programming at SE or HSC level. So it will be an advantage for them. They will find the starting point quite smooth, but don't be overconfident as well. This is also sometimes what I've seen. So students who have already done programming before, they don't give that much effort. So those who have programming skills already, this is a module where you can score A+. So I don't know if your PC talked about it in terms of your CPA. So your CPA is basically going to determine what type of degree that you're going to get, first class to 1 to 2 and so on. So usually students, especially first year students, at some point in time, if you're not well informed, you kind of, so it's not like college where it's first year has no impact. So, par exemple, Form 1 n'a pas d'impact sur Form 2, etc. At university level, all this is cumulative. So whatever you do from your first test till the last test that you're going for the degree will be accumulated together. So basically, my advice to you, not as your programming tutor, but in general, is to ensure that you give your maximum in level 1 so that you bring your CPA to the highest level. In the coming years, level 2 and level 3, what you will be trying to do is at least maintain that level. But first year, really, if you can bring your CPA to the maximum, then it will be easy for you to ensure that you have a good classification in terms of your degree. So this is not like a master's where you get distinction or pass. So here it really matters in terms of what type of degree that you have, especially as at the eve. I'm saying at the eve that these 3 years are going to be very quick in your schedule. So as you are going to proceed in your career path, so it does matter in terms of what kind of classification that you have. So the only thing that you have, forget about the formula, how to do the calculation. The only advice I'm giving you is just to give your maximum in all the modules. Now we also have to be realistic. In some modules, you can easily score an AA+. In some modules, you will be struggling maybe even to pass. So for those modules where you can score highest, bet on them so that it brings your CPA to the highest level. So this was just an aside. So before I move on now, I'm going to start recording. And as usual, before I start recording, I'm going to, everyone has to know that they are in recorded mode. Okay. Just give me a second.
Recording in progress.
Ok, donc bonjour à tout le monde. As of now, you are in a recorded session. So we are moving on to the second lecture on programming. As usual, si vous avez des questions in between, you can either put it in the chat room, or of course, you can voice out your questions as well if I'm going too fast, too slow, or because I have no clue whether sometimes there could be a connection problem issue. So you please let me know as we are proceeding. Okay, donc in lecture 2, what we are going to do, so it says Introduction to C++. But since we have already done our first lab, so you have already been introduced to C++, so we are going to move more deeper in terms of C++, the syntax and all that. Then the second part is related to programming principles and ethics. So here we are going to discuss a lot in terms of what are good programming practices, naming conventions, documentation, and professional ethics. So okay, so this is just a quick recap from what we did in the first lecture. So in the first lecture, we've seen that there are different types of programming languages. So the aim of a programming language is basically to be able to solve a particular problem. And last time we have seen some problems where you can easily use some computational format using programming logic to solve it. Whereas some problems, it's almost impossible to use a program to solve it for you. But having said that, at the same time, since we are moving more and more towards things like artificial intelligence, machine learning, neural network, so this also means that we have more and more scenarios than before in terms of where a program could be used to help us. For instance, let's say you are lost somewhere, and then you have a guide, you have an agent, you have a chatbot. It could basically help you out in terms of finding your direction, where you want to go, and so on. So in terms of levels of different computer languages, I did not emphasize on it last week. It was just the introduction, but just a very brief knowledge. So when we talk about a program, so we initially had what we called low level or machine level assembly language. So these are codes. So for instance, in machine language, if you're not aware, so now you are going to be aware, whatever is written in terms of your program gets converted into binary. So the language that any computer understands is just a series of zeros and ones, binary. So whatever you're going to type as a program, any language that you use, at the end of the day, it has to be converted to low level before it can be executed by your processor. So initially, when people used to write programs, we didn't have like as you have today, very sophisticated. You have functional programming, whereby it's a lot easier to write programs. So when it all started, people had to write series of zeros and ones to be able to write a particular program. So you can just imagine how difficult it was to write even the simplest piece of logic. So as we move on, we have what we call high-level languages, but we also have mid-level languages which can easily create the connection between your low-level and your high-level. So we have, for instance, language like C that we use even for kernel programming. So if you have to access directly, for instance, your operating system, you want to give commands, you want to control your operating system, you can do that via kernel programming, and that uses basically C, or if you're moving on a Linux, so you will see it's the C structure. So studying this programming language in terms of C++ in this module really gives you the advantage of being able to easily shift to a high level. But if you also have to move more towards kernel programming, APIs and all that, so you can also do that. So we also have what we call object-oriented languages. So we are going to do a very brief on that. C++ is actually an object-oriented language, but for the time being, full of semester 1, we are restricting just to the procedural language. We are not using the syntax for object-oriented. Then we have also what we call scripting languages. So scripting languages, for instance, when you're going to design a website, you implement a website. So whatever you write in terms of web pages, par exemple, on peut s'en servir de JavaScript, which is a scripting language. So in this module, we just give you a flavor. There is a lecture where we talk about different programming paradigms. We just give you a flavor in terms of what are the different ways of programming. But for sure, next year in your level 2, you have a full module on object-oriented programming where you're going to use Java probably. And then you also have a full yearly module on web design and development where you're going to explore everything related to how to design a website, what is client-side programming, server-side programming, PHP, Ajax, and all that. So this is just to give you an idea what is also coming up in the future. not only this module, but how other modules are going to build up on the foundations that we are going to cover in this module. So, last week we have seen the different steps of programming, which were related to, first of all, there needs to be a problem. We have seen that if there is no problem, then there is no point to try to design a program for it. Then we have seen what is meant by designing the program. So designing the program was more in terms of building your pseudocode and your flowchart. And then we had what we call write the program. So we have been using C++ in the first lab to write our program. And alongside writing, we have also been testing our program. Donc, durant le lab, I have shown you how if we leave mistakes, your program is not going to compile, and basically you will not be able to see the result. I also already showed you last week how to document the program. So since we have already covered many of the things during the lab session, those who were here last week will surely find this lecture easier to follow. And those who have just joined today, I'm still going through all the materials. Okay, so a program is usually written in a programming language. Okay, we have talked about that. Something that we haven't seen, I haven't elaborated on yet, although I did talk about it, is about syntax. So just like when you write something in English or in French, you have to follow the grammar of that language. Similarly, when you're going to write something in a programming language, you have to follow the grammar of that language. So I cannot write a C++ program just by using anything that I want. So I will have to write that C++ program using the grammar or syntax, as we call it, of that particular language. So I just gave you a brief in terms of C++, how it helps you. So it's a mid-level, so you can easily, so C++ is built up over C. So you can easily use it for middle level kernel programming, APIs, integration from one application to another, middleware. So all this is some of the advantages of C++. So hopefully with time, as you proceed with mastering C++, you will be able to easily shift to other programming. And this is also, as I said last time, all the Python is picking up in the market. So in terms of different scripting, you will see that Python is there in terms of doing things like natural language processing, machine learning. So you have lots of Python codes being used out there. But why I didn't adopt it as a starting point, as I mentioned last week, Python is more functional programming. So there are many things that you will not be able to appreciate as your first interaction with a programming language. And also the other reason is that I did Python programming years back with students, and then the shift to other languages like C++ or Java was more difficult. So that's why I prefer to use C++. Next semester, you have three to four lectures which are going to be on Python programming. So in this module itself, we have some sessions on Python programming. Okay, so now we move on in terms of the program itself, your first C++ program that we have gone through in the first lab sheet. So those who just came in, you just have to follow the first lab sheet, which gives you instructions about how to download code blocks. So if you already have Visual Studio, Dev C++, you can still use that. But as far as possible, I would prefer that you stick to code blocks because there might be some small changes in terms of syntax. But it's not really an issue if you're sticking to Visual C++, that's up to you. So the first C++ program, so when you have to create your project, then you have to create a console application, you choose C++, you have to select the path, and it will automatically create this first program for you. So when you look at the project, you have to go to the main.cpp file, and this is what appears. So in your main.cpp file, this is what you're going to see. You're going to see include IOStream, namespace std, int main, and so on. So we have seen last time what are the meaning of the different terms. This is just putting more all the callouts here just to help you. So include IOStream is directives for the compiler to use the input-output library. So in our case here, we are using cout, which is an output statement. So then this statement is going to be used to it's available in this library. So if you remove this library, you cannot use the cout. Similarly, as you proceed and you will need mathematical functions to use, you will have to include the CMAT library. Then you have using namespace std, so it creates reserves some space, and then you have the int main. This is, so each time you run your program, it's actually going to look for the main function. So if you have a C++ program without a main function, it's not even going to compile, it's not going to run, because this is the first execution step. So from main, then if you have other functions, it can go in other functions. We also have seen ENDL. ENDL is moved to the next line, the semicolon. So this indicates the end of each specific line of code. Return 0, since main is an int function, it has to return 0, which is an integer. But we also tested last time when we set another, so if we say return 10, for instance, it will still work. Okay. Yes, it's worth mentioning. Now I have said int main here, but in sometimes in some platforms, instead of int main, it will say void main. So void mains don't return anything. Void, it's nothing. So then you would not be having this return 0. So this all depends on the compiler that you are using. Though for the moment, all you have to do when you are writing your C++ program is change anything within these two curly brackets. Within these two curly brackets. So whatever you see here, this is what you will have to change. Let me just try to use the laser pointer. Maybe this is going to be easier. Okay, so this is just another program now. If we revert back to the previous slide, if we go to the previous slide. Okay, so if we go, if we go to the previous slide here, no, let's go to this one. So here you see there was just one output statement, cout hello world. Now if we come to this one, you see there are two cout statements, and then each cout statement there are two ENDL, which is saying don't print these two statements on the same line, but go to the next line. And then let's just interpret this again. So cout is just like saying print. Then we have these two arrows, which are like a separator, a delimiter between the command cout and the text. Programming in C++ is easy. So whatever is there between these two codes are going to be printed as is. Then if I want to include another command, I have to put the delimiter again, these two arrows. And then I have to put the ENDL if I wanted to shift to the next line. So this is also the example that we saw last time. Okay, so now we have again two cout statements, but then in the first line, we don't have an ENDL. So basically what's going to happen then, instead of printing these two statements, the black dog was big, and the cow jumped over the moon. These two statements are not going to be on separate lines. They are going to be on the same line. So just after this full stop, there is a space. So it was a full stop space, and then straight away print out the cow jumped over the moon. Okay, again, so this is just showing to you some variations in terms of how within the same cout statement, you can have a mixture of text, command and line, text again, go to the next line, text again. So this one, we will have hello on one line, and then on the next line, oh my, on the next line, when do I stop? Because you have E and the L, which is separating one command to the other. And note where we have the semicolon is only when we have reached the end of the cout statement. Okay, so we are now going to see in terms of input in C++. So just like, and this is also something I introduced at the end of the lab session last week. So just like we have cout statement for output, we have cin statement, which is used for input. Okay, so okay, so we'll see some examples in a while. Donc maintenant on a different data types. So we have seen already in the lab session how to make use of the int data type. So you have all these data types which are available in C++. This is not the full list, you have others also. This is just giving you an indication. You don't have to remember this by heart, what is the byte, but this is just telling you how much space is reserved. So 1 byte is 8 bits. 1 bit can be just one where you can store just one 0 or 1 only, and then 1 byte you can store 8 bits. So this is just telling you in terms of length how many of these. So you have 2 bytes, 2 times 8, 16 bits, 4 bytes times 8, 32, and so on. On the next slide, so this is maybe more interesting for you. So you have a longer list now. So what you will be using mostly is probably int, long, float, double. So you also have here unsigned. So if it says int, it means it can store negative and positive. If it says unsigned int, it means that it can store only positive. So if you want to have, you have a question which says, okay, I need to store only positive numbers, you can define it as unsigned int. Now, in terms of precision, if you need a larger range for an integer, then you would be using a long. So long, as you can see, so it's a long integer. So there is a problem somewhere. They can't be the same for int and long integer. So the values here I was expecting to have different values. So long integer should be able to store a higher range, just like you have here for int and for short. So short, there is a lower range. So for there is a problem here. I don't agree with this. So I just copy pasted from somewhere. So there is a problem in there. A float, donc même affaire pour float, double. So you can have, usually you have float for storing a decimal number, then you have double for increased precision, and same thing, you also have char, character. Character, you can store just one particular character. And the character is not only letters, it can be letters, digits, or any keyboard printable character. For example, a full stop will be a character. A semicolon will be a character. A star will be a character. Then you also have Boolean. Boolean is for storing true or false. Okay. Then you also have in terms of arithmetic operations. So what are the arithmetic operations? Basic one, addition, subtraction, multiplication, division. Note, we already introduced it in lab 1. For multiplication, it's the star sign and not a cross sign. So we have now an example explanation with cin. So we have done something similar in the lab session. So here we are defining first of all our variable mark. We are defining it as being an integer. Then we are displaying some output statements, enter marks, cout enter marks. So enter marks will not do any computation. It will just display the text enter marks. Now we have to capture the value for mark. So we are going to say cin. Cin is same as input. Note the arrow sign. So for cout, it goes on the left direction. For cin, it goes in the forward right direction, which is like saying, if you want to remember it this way, push whatever you have input into this variable, which is mark. And then after input, you are also outputting the marks. We have another example now, but instead of an int, we are using a char. So we are defining char letter. And then we are saying input letter, cin letter, and we are displaying the letter. If we compare the previous example, so here we also have some indication in terms, it's saying us, it's going to tell us enter marks. Compared to this one, when we run this program, we are just going to see a blinking cursor, and then we don't have any indication in terms of what we have to do. So it's very important that we give directives to the person who's going to use that program. So it's important to give instruction what the person is supposed to be doing. Should he input a number, a name, address, a telephone number? So it's you as the programmer, you have to give proper text at different instances. So this was example with showing you how to use a char variable. So we have seen int, we have seen char. We also have the string variable. So if you want to be able to capture, for instance, a surname, an address, and so on, you can't just use the char character. So the char variable data type. So the char data type can store only one character. So if you have to store more than one character, just like in name, address, street name, and so on, then it will be a string. So you define it as a string. I haven't seen the inclusion of include string library. So depending on your compiler, sometimes it's already inbuilt. You don't have to include the string library before you can use the data type string. So if it doesn't work, what you do, you just say hash include open bracket string close this bracket. Okay. The same thing. So we define string letters. So now the variable letters can store more than one character, and then I'm going to input and output it. The only thing that you need to be aware of is that if you define something as string and you do a cin, it's not going to accept any spaces. So if I have an address like 31 Street, du Pamplemousse, or whatever it is, so whatever you have in the first space it encounters, it skips the rest. So there is a way then to ensure that when you are going to capture a variable of type string, you can also capture the space. So for the moment, what you do, just write it somewhere. I hope even if we are doing online, you still have a copybook to note things as we are moving on. So what you are going to note already is that if you want to capture a string where you can have spaces in between, just like name or address, then instead of using cin like this, you have to use cin together with getLine. Okay. I hope there are some examples here. Otherwise, you can find lots of examples available online. So yes, one of the things in this module, just like in any module that you're going to cover, it's impossible to cover 100% in terms of what's there that we want you as students to be able to capture. So we are giving you the drive, we are giving you the guides, we are giving you additional links. So it's important that you continue in terms of self-learning. That year we have shifted to LCCS, which is ECTS credits, whereby you will see for each module in the module catalog, there are hours reserved for you as students who have to do self-learning. Just to give you an example, so your labs are like 1 hour contact only. So this depends on tutor. Sometimes I do more than 1 hour with my students, but then in terms of contact hours, you have 1 hour, and the remaining, it's supposed to be you doing it as self-learning. So the labs are not meant for you to come here and do everything during the lab session. You're supposed to have already worked out the questions. The lab is more interactive, where you come and discuss problems mainly. Okay, so we have another example now. So instead of defining one variable, we are having free variables. So now, since there are free variables, you don't have to define 3 different lines: int test, int exam, int total. You can define it in one line itself, but then it has to be separated by a comma. Note the difference between the use of a comma and a semicolon. The semicolon determines the end of a statement. The comma is separating one variable to the other. Okay. In this example, we also have a comment line. So if you put 2 backslash like this means that it's a comment line. So this will have no impact on your program in itself. So you can insert comment lines at whichever point you want in your program. And it's also, while it's important that you include comments in your program, it's also, it's also important that you don't bombard your program with lines of comments. So if your program has 100 lines of code, we are not expecting to have 100 lines of comment, one for each line. Okay, so you have to use your comments judiciously. So this will be, for instance, for a block of code to say what this code is doing. Is it for some computation, for some calculation, for any exceptions that you want to throw, and so on. So in this example, we have 3 variables: test, exam, total, and then we are inputting the test. So these are some directives, just some comments which are going to be there. Enter marks for test, you input test. Enter marks for exams, you input exam, see in exam. You do the computation, total equals to test plus exam, and then you're going to output the total. Now see the total now, where the total is going to be output. So it says see our total mark is. So this part, total mark is, will be printed as is. But we also need to print the value which has been accumulated in the total. And this is stored in variable total. And that's why you need to separate the text and the variable with this delimiter, these 2 arrow signs. Okay, write a program that requests the user to input the radius and calculates and display the area of a circle. So we'll try to do some examples during the break. So write a course design for all the flowcharts that you have. So that was not week 2, sorry, that was week 1. If we go back to this slide, just a reminder again. For this module, you are being given each week some lab sheets for questions that you need to work on. But you have also been given 2 different links. One is for W Free School and another one where you can do additional tutorials. So the more you practice, the better you are in terms of skill set that you are getting for programming in C++. Okay, so don't restrict yourself to just what we are doing in class and what is proposed in the lab sheets. Okay, so now we also have special characters. So what are these special characters? For instance, we have just seen the use of these 2 backslash, double slash, which determines the beginning of a comment, the pound sign, which determines the preprocessor directory, directive, include IOStream, include string, include CMAT. The opening and closing bracket where you have, this is for your include. So which file name, which API, which library you want to include. You also have the opening and closing parentheses. So this is for use mainly in a function, int main. For the moment, we are using just main as a function, but later on we will be having other functions like, I don't know, calculate VAT, work out addition, calculate total marks and all that. Then we are going to have more things added within the brackets, which are going to be your parameters. So just this is just to give you a hint for the moment, because now whatever program you're going to run, there will be this int main with bracket always. You can try running your program by removing these two brackets and you will see it's not going to compile. The opening and closing braces. So these are basically to group some statements. For instance, for the moment, everything which is in main is regrouped within these two opening and closing braces. Then you have opening and closing quotation marks. So this is basically for text that you want to include, and semicolon we have just seen. Okay, so some more escape sequences now, common escape sequences. Look, we haven't seen all these so far. For instance, instead of using ENDL, you can use /n. /n is saying go to the next line. Or if you want to leave tabs, for instance, you can use /t. If you want to beep, you can use /a. If you want to use a backspace, you can use /b and so on. It's nice to note that if you want to print backslash, then you have to precede it with another backslash. And if you want to print the code, a single code, you have to precede it again with a backslash. Same thing for the double quote. I mean, if you want to print it as a text, okay, otherwise it's just going to be interpreted as being a text and it will not be printed. Okay, so having said this, the next part is talking a bit about what are good programming practices. Any questions so far before I move on? So I don't see anything on the chat.
No.
Okay, no questions. So I'm just going to move
Yeah.
on. So this part here, in terms of good programming, this part is quite light. So I just want to cover this part and then we break and then we'll move on a bit more in terms of programming. So this, in terms of good programming principles and ethics, this has nothing to do in terms of your program in itself, but it's more in terms of good practices, good habits for quality assurance. Just like any product that you build, whether it's a new pen, it's a new car, at some point in time, there has to be quality assurance in there to ensure that your final product is of high quality. Similarly, for programming, we have different principles, standards that have to be followed to ensure that your program is of high quality. So we start with good programming practices. So what are good programming practices? So for example, instead of just giving variable names as X, Y, Z, it's better to give them meaningful names. So if I'm going to store marks, I'm going to say int marks. If it's the total, I'm going to say int total. And also, what's very important, why it's important to have these good practices is for yourself when you revert back to your program after some time. If it's a small program, 10 lines of code, it will be easy for you to trace back what it's doing. But if it's a long program, 100,000 lines of code, then it's going to be difficult for you to really understand what's happening. So it's important then to give good names. Use consistent naming scheme. We are going to see in a few minutes what are naming scheme, one sample of a naming convention. make use of indentation. So what is indentation? I haven't talked about indentation so far. If we go back to one example, let's say this one. So here we are having int main, then you see these curly brackets and you see there are some space. So this will be automatic. This is what we call by indentation. So you leave some space to ensure that it's easier to read your program. So I know that between these two brackets, all these are in scope for the main. As we proceed and we add more in terms of, for instance, looping, conditional structures, if then else, you will see that how indentation is automatically going to be added as you add those lines of codes. At the same time, it's important to know that indentation has no impact on your compilation. So if I remove all these indentation and I compile it, I just make it align with these two braces here, it will still compile. There will not be any problem. So this is just for clarity, readability purposes. Donc ça c'était indentation. Hard coding. So hard coding should be avoided as far as possible because this makes your program less flexible. What is one example of hard coding? Let's say I'm playing a game and the maximum marks for the game today is 20. So instead of hard coding the value 20, I will be creating a variable max, which I can enter, I can change at any point in time. So when I run my program, I can, for instance, ask the user, do you want to change the value of the maximum? If he says yes, I'll allow him to change this value. Otherwise, I can take a default value. Regroup your codes in functions. Donc, on n'a pas encore fait ça. In due time, what we are going to do, we are going to see how we can use different functions, which makes our program more modular. I take an example just for you to be able to visualize what I'm talking about. Let's say I want to create a calculator program. So I want to simulate how a calculator behaves. So in a calculator, you have different functionalities. I take the basic one, addition, subtraction, multiplication, division. So when I run my program, I see some kind of menu for addition, subtraction, multiplication, and division. And then when I select addition, it doesn't go into that main program. It goes in a function which is separate from the main program to do addition. So in this way, I'm not putting everything, I'm not putting all the load on just one function. So it becomes more modular. And if tomorrow I want to extend, I want to add more functionality in terms of adding trigonometric options in my calculator or adding modulus in my calculator, it will be easier to add that. I just have to add a new function. So don't worry if you don't really understand what I'm talking about at this point in time. We have we have 2 weeks on functions. Avoid deep nesting. What is meant by nesting? So nesting is when you try, so you're using the same code and trying to go too much into detail within the same program. And basically, when you use functions, this kind of already solves part of the problems related to nesting. Okay. Use naming convention. So how do we use naming convention? I'm proposing one naming convention that we are going to use for this module. For example, if a variable is an integer, we are going to precede it with I. If it's a character, we are going to precede it with C. If it's a string, we are going to precede it with S, just like we have here in these examples. And if it's a Boolean, we are going to precede it with B. If it's a float, we are going to precede it with F, and so on. And then we are still going to use a meaningful name. So as of now, when you're writing your C++ program, don't forget you still have to do the different stages, define the problem, then design the solution, and then coding. So you still have to use pseudocode, flowchart, but before that, identify output, input, process, and then do the program. So you still have to do those stages. Okay, documentation. So I already talked about documentation, the importance of having documentation. At the same time, I have talked about only program documentation. That is, within your program, what are the comments that you can add. But you can also have documentation which is accompanying your program, like a manual or like a configuration file or setup file that you need to add up together with your program. So this is very important when you're writing your codes. Always have this in mind. You're writing your codes not only for yourself. You are writing in such a way so that tomorrow, if someone has to pick up from your program and has to add on to it, they can easily do that. Unless you're doing it on purpose and you want to maintain sole ownership of whatever you're doing and you're using some techniques which prevents others from really understanding what you are doing. Otherwise, when we are talking, I'm talking about team projects. So you will be working in companies. You will have usually companies who are well structured. They follow a quality assurance process, and they will force you to use some kind of method, some kind of procedure, naming convention, or if they use a very formal quality assurance. So here we have what we call CMM, CMMI, which is basically used in the context of software. So it's the quality assurance that companies apply for software development. So we also have Six Sigma. So I'm not going into the details, but it's just worth highlighting that even in the programming world, in the digital world, we still have to ensure that there is quality. And it becomes even more important since usually you don't see you don't see it as a tangible product. It's a software that we are creating, so it's even more important to ensure that there is quality at the same time. Okay, program documentation. This is just giving you some more information. I have also put some source out here. Just for your information, there was a link which was not working in the lecture one. So sometimes when we have put some link, after some time, maybe the link is not active anymore. So if you, there are problems like this when you're going, because I'm not checking all the links every time. Sometimes I'm updating. So if there is a problem with the links and all that, just let me know and I will update. So for lecture one, I did add a new link in the classroom itself. Okay, so sample program documentation. So what are some of the elements that you can include as sample program documentation? For example, the author information, the program description, any calculator requirements, installation, and so on. So this is just one typical example of what to include as program documentation. It's not like full-fledged, it's not exhaustive. It will all depend on your scenario. If there are elements that you don't really require, you won't add them. But if there are elements which have to be added, you would add on to this list. Okay, so this is again more on program documentation. So this is an example that we also did last time. So those who are not there, 2 backslash, as I already showed in a program, this is for commenting one line only. So if you want to comment a block of lines, then you will use /* and */2n. And in between, you can have any number of lines that you want. So for those who have just started using code blocks already helps you in terms of by using different colors to show whether, so if everything is grayed out, you know that it's taken as comments. So if for some reason, maybe you started a comment and you forgot to stop it, so then the remaining text will be grayed out. Otherwise, it makes use of the colors like green, blue, to show you different use of different syntax elements. Okay, so you can also have, as I said, you can have a program documentation as a separate file. So it can be just a text file, a PDF, or it can be a text file, sorry, a PDF, or a normal Word document. So which program documentation style in this module? So in this module, as I said, we are focusing more on program documentation itself, but feel free to add any other documentation which you feel might be required. As an aside, you will have to do an assignment on gaming. So you will have to design to implement a game. So in that, probably apart from program documentation, you will have other types of documentation, and we are helping you out in this direction by giving you templates in terms of what you should be giving us. Okay, so rewrite the program that you were supposed to do for circle, calculating area of circle using good programming standards. And this here is talking about is using good naming conventions and also using documentation. Okay, so the last part is in terms of professional ethics. So what does ethics have to do with regards to us studying a module on programming? So ethics, first of all, you need to understand professional ethics are a set of rules, regulations, code of conduct that governs how a profession deals with each other, and also with others outside their profession. So it's very important that you have what we call work etiquettes. So even here as a student, you're expected to have a good code of conduct. And if you do not respect this, then in worst case scenarios, there can be disciplinary action which can be taken against you. So this code of conduct is not only for you as student, but it's also for me as a tutor. So how should I be addressing my students, what I can share with you and not share with you? Let's say, for instance, I want all my students to score A+ in this module, and I give you already the test paper prior to you sitting for the test. So this is highly unprofessional, unethical. And of course, this is not something I'm ever going to do, but just to show you an example of how even a tutor can be unethical in his or her profession. So for you, we expect you not to be cheating. We expect you not to be working on the assignment for others which are not scheduled for you. At the same time, when it's group assignments, we don't expect only 1 or 2 students to be working on the assignment. So it should be shared. It should be well balanced so that we don't have free riders. So if there are free riders and you're not able to control that, whatever module you can talk about that, you can send an email to the tutor concerned. Okay, so why should I, as someone who's studying programming, be concerned about ethics, code of conduct? So what you should be aware of is that as a programmer, if you are not careful in terms of your program, this could even cause harm, and in worst case scenario, it could even kill people. So you have to be very careful. Think about all those applications in terms of safety applications where we have car, airline companies, in terms of the finance sector, health. So all these are very critical applications whereby if we are not careful in terms of our coding, it can cause a lot of damage, and in worst cases, it can even kill a person. Think about a surgery, an online surgery which is happening. So if there is the wrong data which is being sent, so there is a module, a function which is related to maybe cutting something. So if it launches that function at the wrong time, then you could even end up killing a person. So you have to be very careful when you are coding something. And does it affect you as a programmer? Yes, it affects you 100% because you don't know in which domain of application you will be coding. You could be coding for a car company. You could be coding for an online reservation company. You could be coding for health related matters, for farming, for surgeries, pharmaceuticals. So at some point in time, it could be something which can be harmful to people, even for finance, Very critical again when you're going to manage different accounts, security, privacy. So you have to be very careful. And this is why it's important that you know what it means by professional ethics in computing. So one of the things that you need to be aware of is that when you're going to write your codes, it's not enough to write your program and make it run. A program which is running is not necessarily serving its purpose. It's not necessarily correct. So it's very important then that you apply different types of testing. So we have already started here by introducing what's testing, but we'll do more and more in terms of applying testing in a very systematic way to ensure that you haven't missed anything out. Even if we do that, it's worth mentioning at this stage that it's impossible to create a program which is 100% bug-free. There would always be some perf that you have not tested. So, but as far as possible, you as a programmer, you have to ensure that you have done enough testing to ensure that the program is reliable and can be sent to the live environment. I'm just mentioning one term here. When you're writing a program as a developer, usually your program stays in a development environment. So there you can test, you can run different scenarios. Once you have done rigorous testing, quality assurance, regression testing, then you can move your program to the production environment. The production environment is where the program is live. So where people who are going to do real transactions are using it. So when the program is live, you cannot afford the program still being in a testing phase and sending it to live. So there has to be rigorous testing before that. So all this you are going also to be doing in your module, which is related to software development life cycle. So one of the steps out there will be testing. So you are going to see different methodologies. Like for instance, what's popular now is the agile methodology that you're going to see as well. So you have some reading materials here to enhance your knowledge in terms of what a code of ethics in computing. So please go through them. And as of now, for any programs that you're going to write, so it should be using good programming principles and practices, naming conventions, good commits, and so on. So we'll be doing more in terms of high quality programming in semester 2. So for now, this was just a flavor, starting with program documentation and also with good naming conventions. Okay, so with this, I'm going to stop recording.
Recording stopped.
So as of now, I have stopped recording and I welcome any question that you might be having. Any question? Anything which was not clear that you want me to pick up again? Any question with that? So let me see the chats. Good, good, good. Everything all right? No question. Okay. So since, just to let you know, okay, we have a question out there. For cha, it is only one word, but why there is a limit to 127? There is not only one word for cha, there is only one character. So one character could be a letter, A, B, C, D. It can be a number, 1, 2, 3, 4. It can be any keyboard printable character, full stop, equal to sign, star. So all these are what can be stored in your character. Okay, so if we have to go in terms of what is there in terms of how each character is now stored inside your computer. So basically, we have what we call ASCII codes. This is something that we are going to deal with when we cover the chapter on string, but just for you to have an idea, why is it that when I'm saying one character, the limit goes up to 127? So even if it's one character, I'm saying I want to store the letter A. So to be able to store the letter A, it's not going to take only 1 bit to store that. So there will be, I don't remember exactly how many bits. It's a 127, it's 8 bits. So it's going to store, then I need this number of bits to be able to store the character A in binary. Because I will also have to store, so each character will have a combination, a code, what we call ASCII code, and each ASCII code gets converted to its corresponding binary number. So to be able to represent all the keyboard printable characters, I need to identify how many characters I have, and then based on that, how many bits I will require to store them. So I'm not going to go into further details. It's just to give you an indication that when you say letter A is not only stored in 1 bit. Letter A requires more than 1 bit to be stored inside your program. Does it answer your question? That was a question from Muntasir. Is it okay?
So we can store a letter up till 127 bit.
Forget about the bit. The bit is just for internal representation. The number of bits which is here, this is, so just imagine, okay, let's take a simpler example. Let's say you have 10 characters maximum to store. Okay, how many bits would you require? Can you respond to that?
In terms of bit, I don't know, but
Exactly. No. So that's why I'm saying that I'm not going to go into that detail. So there is a conversion that we can do, which is not in scope for this module. So basically, when you have a certain number of bytes, a certain number of bits. So if we say, for instance, if I say only 1 bit, with 1 bit, the maximum number of combinations that I can store in that 1 bit is just 2. I can either store a 0 or a 1. If I expand in terms of the number of bits, I say, okay, now I have 2 bits. The number of combinations that I will be able to store will be 4. How do I get that 4? It's 0, 0, 0, 1, 1, 0, and 1, 1. So there is a formula that we use usually depending on the number of bits to know what is the maximum number that you can store in a given scenario. Give me a second, my battery is going down. Okay, do you get my point?
yes, Miss, thanks.
Okay, so unfortunately was that I'm not going to go into the details. So this is, I'm not sure if you do it in another module, but this is really out of scope of this module. So this has to do with the conversion of decimal to binary. So decimal is whatever you know, whatever you've been learning. So when you say the digits 0 to 9, this is the decimal, this is known as decimal. So I put it, okay. So this is a decimal number. So each decimal number has to be converted to its corresponding binary before it can be represented inside your PC. Okay, so there's another question. Will we get tests on the theory part like the ethics? No, there is no, the test, as I said earlier, the test itself will not be strictly on the theory part. We expect you to be including these when you're going to write your programs. So with regards, so I will not ask you a question like, what is professional ethics? What is naming convention and all that? No. So, but in my question, I expect you to be able to write that. For instance, in my question, I can say, okay, write program to do whatever it is using good naming conventions and documentation. So then you know that when you're writing this program, you have to include everything with regards to naming convention and all that. But there is nothing like theory related question. The only theory related part which you could be having is, for instance, I give you a program and I tell you, okay, you have to do different types of tests. I give you the test plan, but that's also not theory, it's applied. So there is the program, and then you have to tell me, okay, for this program, what are different test cases that you could be using to test for different scenarios with normal, abnormal, extreme data, and so on. Okay, so I hope this clarifies. Any other question I missed? No? Okay, so what we are going to do, since we are ahead of times and I hate wasting time, so we are supposed to be finishing at 1:30. So what we are going to do, we are going to have a short break as per my clock. So as per my clock, it's c'est 12:45. Donc we have a break jusqu'à 12:55, 10 minutes, and then I'm going to already start the next lecture. Okay. So when we have time like this, I prefer to move on because the lecture was quite light today and we had done many of the things already in the lab session. So when we have time, I will be moving on to the other lecture because you will see that for some topics, it's more bulky. Then maybe instead of using 2 hours, I will use less. Because at some point in time, if I find that students are not able to follow, it's too much to absorb, I will just stop. So for today, we still have 45 minutes, which is not going to go wasted. Donc, vous avez un break maintenant, 10 minutes. On se revoit à 12:55. C'est bon? Et in between, si vous avez des questions, n'hésitez pas. You can talk to me, I can still be here, or you can type it in the chat room. Merci. I see a question on the syntax between C and C++. I'm going to pick up that after the break when everyone is here. Merci. Okay, I'm back. So let's move on. Okay, so we have a couple of questions. Can you explain documentation one more time? Okay, so documentation, basically we have different types of documentation, if I can put it that way. First of all, you can have documentation within your program. So why do you want to have documentation within your program? Is for you yourself. If tomorrow you are going to look at this program again, you know what this program is all about. It's easier for you to pick up. But mostly now when we are talking about codes working in groups, it's mostly working in groups whereby someone else might have to pick up your program. Donc, as I said earlier as well, the new job of a programmer now is not to write everything from scratch, but to be able to use whatever is already there and extend on it. So why do you have to recreate the wheel when it's already there? So this, having said this, it means that it's important if you have access to a particular function, for instance, which is doing something that you can plug in your existing program, there should be enough documentation out there which tells you what the program is doing. Donc, ça c'est the first level of documentation where you can insert comments within the program. At a second level, you can also have documentation which goes outside your program. Don't just think about nowadays what you have as documentation outside your program is basically FAQs and help tools. So when you're installing a new product, you have accompanied to that product a help feature which is mostly online now. So when you click on the help, it brings you to a particular website where you can have assistance. Sometimes it's even via a chatbot, but also you can have lots of FAQs which are out there, which helps you out in terms of how to use, how to operate this program. So this is all what we have been seeing today, and I showed you in terms of example how to add just one line of comment within your program, or for adding multiple line of comments, what's the syntax. Donc ça c'était pour the first question. The next problem is more in terms of connection issues. So unfortunately, I can't do anything about that. So if you're having lots of connection issues, maybe you can, I don't know, sometimes students, what they do if they're having issues with, I don't know what kind of package you have, but you can also buy a monthly package and make your mobile phone, for instance, become a hotspot if this works for you. I'm just sharing with you because I can understand sometimes in the region maybe you are, maybe network coverage is not good, but unfortunately these are technical issues that I cannot do anything about. Do we need to do lab sheet 2 for Wednesday? Yes, Fuzan. So I already talked about it. So basically when you're coming to the labs now, so we are covering the lecture. So prior to coming to the lab, you have already done the lab, and it's more discussion session. And I have also sent to all of you the different schedules. So you will see that I have reserved 1 hour slots with 2 groups combined, because most of the time it's the same questions that you are getting, but I have also reserved 2 additional slots for any other questions that you might be having. So most of the questions would probably have been covered during that 1 hour that we have, but I have also reserved, so as per your schedule, as per your timetable, so it doesn't clash with anyone. So there are additional 2 1-hour slots. And of course, if I'm there for the first 10 minutes, no one is here, I'm closing the session. But I have reserved this space for you and the links provided to you. When are we going to correct tutorial 1? Tutorial 1 is still, so I have the answers already for tutorial 1 that I have not posted yet. So that will come in due time. So that's going to be before, of course, your test 1. So the answers will be given to you, and then we are going to see what are the problem areas during the lab session. If you guys have, do you expect us to include validation? So I haven't really talked in terms of validation yet, but if you have already done programming before and you want to include validation, yes, please go ahead and do that. Can we use lecture hours to do some lab sessions so that we can get more practice as we only get 1 hour? No, but that's the aim of having these 2 additional hours. So I'm going to have this 1 hour contact with you for troubleshooting any problems that you're having. But then there are again 2 hour slots that anyone can join in if you're still having problems. Okay. So basically, just to make it clear, okay, as per your schedule, you should be having 2 hours contact for lecture that I'm doing now, plus you have only 1 hour contact for lab. But however, I have planned it in such a way so that you can have more than a 1 hour contact for your lab. So that are those 2 additional spaces that I have put in there. Okay, so this provision has already been made for that. Okay, so let's move on now. I'm going to share my screen with you. So as of now, you should be seeing my screen. Yes, you can see it. And I'm going to turn off now the video and I'm going to start recording.
Recording in progress.
Donc, rebonjour tout le monde. As of now, you are in a recorded session. So we are moving on. We are still in week 2. But since we finished earlier, we are moving on to lecture 3, where we are going to discuss a bit more details in terms of data types and expression. So we have around 30 minutes. So let's see how far we go. At least I have already introduced so that next time when I'm picking up this topic, it goes on more smoothly as well. Donc, this is what we are going to discuss today. What are variables, constant, identifiers, data type, and arithmetic operations. So basically, most of these items here, we have already been using it in our program. The only thing is that we didn't give a name to it. I didn't tell you, apart from variable, I didn't tell you that this is an identifier, this is a constant, and so on. So this is what we are going to see, because given any question, if we use the term constant or identifier or variable or keywords, you should be at ease with them. You should know what we are talking about. Okay, so if we have a look at this program now, so in this program, we have X, Y, and Z, which are variables, and then we have 5 and 10, which are constants. So this 5 and 10, the value is static, it's not going to change. Whereas X, the value that you can store in X in itself, this can change. So X is then basically going to be known as an identifier. And then the values that you see, the fixed values, 10, 20, 500, 15, all these are constants. So variables, as I already said, represent a storage location in a computer's memory. I did not use the term storage location as analogy. I have been talking about container. So these containers are basically storage locations inside your computer's memory. Just like we were talking earlier, we said char. So char can hold any character. So this character has to be stored somewhere. I need to reserve space so that my program is going to store this character. Now, variables are going, if I say int x, x becomes a variable and there is space allocated to be able to store an integer variable. Constant or data type, data item, whose values cannot change while the program is running, as I said earlier. So these are static. These are static, these are fixed values, and they are not going to change. So you should be able to identify the variable names in this program. So I think it's quite straightforward. You have number, which is a variable name. Do we see anything else apart from number as variable name in this program? No, I can't see anything. So there's just number, and then we have the constants 5 and 7. Okay, so in terms of constants and variables now, so you have, for instance, uppers equals to 20, so 20 becomes a constant, uppers equals to 15, 15 becomes a constant. So this is just to show you the difference between a variable and a constant. Maybe before I move forward, it's just worth mentioning. So sometimes I have seen this as typical mistake. So I have int uppers. Uppers is a variable name. So I want to assign the value 20 to uppers. So whatever value which is on the right is going to be sent to the variable on the left. If I say the reverse, this is completely wrong. What I mean by that is that if I say 20 equals to uppers, this is completely wrong. So my variable is always on the left, and the value that I want my variable to hold will be on the right. And the equal to sign that I have here, this is known as an assignment statement. Later on, we are going to see whereby we can use two double equal sign, which represent checking for similarity. I'm checking whether the value of A equals to 5, for instance. Okay. Donc, ça c'est integer constant, string literals. This I have talked about it. Now, an identifier. What are, so for instance, variable names are examples of identifiers. You can have function names also, which are going to be examples of identifiers. So there are rules to follow when you are going to define an identifier. So a valid identifier is a sequence of one or more letters, digits, or undersigned symbols. So if we want to have a variable, for instance, address line 1. So address line 1, I'm not going to separate it with a space. This is not going to be valid. I can say address underscore line underscore 1, for instance. This then becomes a valid identifier. Also, you cannot start an identifier with a digit. This is not valid. So neither space nor marked letters can be part. Only letters, digits, and underlined characters are valid. Okay, so these are the rules to follow when you're going to define a new identifier. And also, you cannot use any keywords. Keywords are those words which already have a meaning in the programming language that you are using. For example, int, main, bool, char, all this you cannot use it as a particular variable name. We have mentioned some more here, although we haven't done it yet. So break is a reserved word that you're going to use. Case also is another reserved word, so you cannot use them. Anyway, when you write your code blocks program, if you're using a keyword, you will see the color appearing as a keyword. So that you then know that you cannot use this to define an identifier. So these are some, it's not a full list, but these are some of the keywords that you have in C++. And continue, go to, public, struct, extend, char. So all these are identifiers which you cannot use as variable names. There was a question in the chat room which was about whether there is a big difference in terms of C and C++. So the syntax that we are using to write our programs for the moment, we are using procedural programming, but we are also using C++ syntax. So for example, instead of using printf, we are using cout. Okay, so instead of using scanf as typical C program, we are using cin. So it's not going to be a very drastic change for you when you move on to purely C++ object-oriented programming. The only thing which I'm not doing for the moment to avoid any confusion is the concept of classes and objects and polymorphism and whatnot that you have in object-oriented programming. Because this, for me, this comes after the student has acquired basic skills in terms of writing a piece of logic. And what are those basic skills? Those basic skills is being able to define a variable, being able to use branching instructions, if then else, being able to do looping, for loop, while loop, being able to do to write functions, being able to manipulate file, being able to work with arrays and strings. So once you have mastered that, then the shift. So these are the building constructs that you need to write any C++ program. Once you've mastered that, then the shift to doing writing your program using classes and objects is not going to be that difficult. Now, for the moment, I'm not touching that aspect. Some C++ variable names which are legal and illegal. This is just to give you some examples. The day of the week, this is legal. It starts with a letter. Free D, this is illegal. It cannot start with a digit. Underscore, this is legal. You can start your variable name with an underscore. June 1907, this is legal. The number comes after. Mixture, hash free, this is illegal because you cannot have a special symbols. It's only letters, digits, and underscore that you can use to define your variable name. Okay, so for some reason, since I'm not using my headset, so if there is background noise as I'm moving and you're not able to follow, so please stop me and I will explain again. The declaration of variables. Now, this is something we have seen already. Int A, you can define it as, if you have three different int ABC instead of three different lines. If my number is a float to store decimal numbers, then I can say float my number. Okay, so in order you have to, okay, so how to define an initial value, how to initialize your variable. You can write it like this. For instance, int A equals to 0 at definition time, or int A bracket 0. I think we did one example like this in the lab last time. So if you want to ensure that your variable has a valid value, it doesn't store garbage. Now, what is garbage? Sometimes what happens, I remember last time one student was telling me he or she has done a program, and then when it prints, it's printing a number that they have not input at all. So this is what garbage is about. So if you define a variable, we just say that a variable is allocating space in memory. You could already be having something stored at that particular memory location. So if you want to ensure that your variable is clean, is initialized right from the beginning, if that variable at the initial state should be storing 0, you just initialize it with 0. Or you force an input to ensure that it's holding a valid value. If you don't assign it to anything, and then it will be referring to a memory location which already has some value, and it will be just outputting that data. Okay, constant now. So so far we have seen constants in the form of just numbers 1 to 3 without really having any meaning as such. In some scenarios, we want to be able to define a constant. So for example, there are some values which are going to be, static during the full program. For example, pi, the value of pi doesn't change. If you want more precision for your pi, of course, you can add on more decimal, 3, 4, 5 decimal places here for pi. But then how you define it? So you can say define pi 3.14 then the name pi becomes a constant, and you can just use pi at any point in time in your program. So we refer to this example where you had to calculate the input the radius and calculate the circumference and area. Okay, so in this example here, we are using the constant pi. So we have defined pi. Note where that, note the place where you're going to define pi. It's before the main. So all the constants that you define is usually before the main, so that you can use it in the program at any point in time. So here you are defining pi, okay, and then you have defined your variables f radius, f circ for circumference, and f area. Then you're going to input the radius in f radius. You are calculating the circumference. Sorry, there's a typo here. It should have been f circ and f area. If you run the program as is here, it's going to give you a syntax error because circ and area have not been defined. So it's good that we have typos in these programs so that when we are looking at it together, we can identify the mistakes, and I can also discuss the mistakes with you. Donc, the circumference is 2 pi r, so 2 times pi times r, okay? Note, if you just put 2 pi r without the multiplication sign, it's going to give you an error. So whatever mathematical notations that you have, your program does not understand. It only understands the mathematical notations that has been encoded in it. So for the moment, we are working with addition, subtraction, multiplication, division. So you have to explicitly make use of these commands. For instance, if I say 2x, it's not going to work. I have to say 2 times x. Similarly here, 2 pi r is not going to work. I have to say 2 times pi times r. Same thing for division. So you cannot use 1 over 2. So you will have to use the backslash for your division. Okay, and then we are displaying, so we are calculating the circumference, the area. I repeat, it should have been f circ and f area instead of circ and area. And then you are displaying the circumference. So here it's correct, f circ and f area. Okay, basic data types. Okay, I already discussed about this. I'm not going to talk about this again. So more on operators now: addition, subtraction, multiplication, and division. Note that we are still having to, we can't go too much in a rush in terms of writing our program. We have to, first of all, show you the basic syntax, the basic building blocks. Then only we are going to move ahead. So we have here in terms of make use of arithmetic operations. So this is just to show you how to make use of the add operator plus, okay? So I'm calculating sum. I have 2 values. I'm calculating the sum and displaying it. We also have added here the modulus operator. So the modulus operator, this is where you can calculate the remainder when you have a value divided by something. So if I say 1 divided by 3, instead of 1 divided by 3, I say 1 modulus 3. What is the remainder when you say 1 divided by 3? Anyone?
1.
Okay. Instead of pi, can we write pi times radius power? Okay, so before we move on, there was a question in the chat room here. Instead of pi f radius times f radius, can't we use pi times f radius power 2? So the way you have typed it here, it's not going to work. You have to make use of the function power. Okay, so you can use the function power as we did last time, POW bracket radius virgule 2. Okay, so this Arusani, this is not Chishapula Sasavapamoshe. Okay, so now the question coming back to modulus. If I say 1 modulus 2, so as we have seen here, modulus gives us the remainder. I'll take it the other way around. I'll go back to what you used to do maybe in standard 3 or 4. If I say 6 modulus 3, what's the remainder? Is 0, right? Because you have said how many sets of 3 can you have in 6? So you can have 2 sets of 3 in 6 and the remainder is 0. Same thing now, when I say 1 modulus 3, how many sets of 3 can I have in 1? I cannot have any set of 3 and I have 1. So I'm not using it, so the remainder is 1. If I say 2 modulus 5, what's going to be the answer? What's the remainder when I say 2 modulus 5?
2.
It's
2.
It's 2. The remainder is 2. So I cannot have any sets of 5 in 2 and the remainder is 2. So this is a very important functionality that you're going to use in different programs that you're going to write. So it's important to understand how to use it. Okay, so here we have some examples. Someone asked me last time in terms of what's the precedence of arithmetic operation. Is it the same as BODMAS? So it's not exactly the same as BODMAS. This is the order of precedence that it uses. So it first applies brackets. Then you have unary. Unary is, for instance, if you have negative x, then it uses multiplication, division, modulus, and finally it uses addition and subtraction. So to be safe, when you are writing your programs, when you have calculation, do make use of brackets. Don't just type the full expression because then it will apply order of precedence and this might not be something that you want. So do make use of your brackets properly, just like you type any mathematical formula. If you don't want it to apply BODMAS straight away, so you make use of your brackets. So if you evaluate these expressions using the order of precedence, these are the values that you're expected to be having. For instance, if we take the first one, 5 plus 2 times 4, so it applies multiplication first. 8 plus 5 equals to 13. So if you do the same thing for the rest using this order of precedence, highest to lowest, these are the values that you should be getting. So you please try them. And then in the next lecture, if you're having issues, we can go and check what's the problem, why you haven't been able to get the answer. Increment and decrement operators. So this is the last thing that I'm doing, and then we're going to stop. So what's the increment and decrement operator? So if this is, let me just use an example, it will be easier to explain. So if I say x plus plus, this is same as saying x equals to x plus 1. If I say y minus minus, this is same as saying y equals to y minus 1. So this is just the shorthand format for saying x equals to x plus 1. So you're incrementing x by 1, and for y, you are decrementing it by 1. So I think I'm going to stop here for today. I'm losing my voice. Good. And also, I'm going to come back to it for the increment and decrement operator next time.
Recording stopped.
So I have stopped recording. Good. As of now. So now if you have any question, I can take them up. Let's say in the chat if we had any questions first. Okay, so there are no further questions in the chat. So do you have any other questions that you want me, anything else that you want me to go through? In terms of explanation, that's it. I'm not going to go further today. Especially for the increment and decrement operator, I like working out examples with you. Okay, because we can have x plus plus and plus x, which can have different meaning. So this I'm going to take next time. Anything, any question before I end the session for today? Okay, so we don't have much in terms of what was supposed to be covered for this lecture. So for next lecture, I'm going to complete this one. Plus, we are already going to start up with decision structure, if then else. Let's see if we have any questions. No further questions, no further questions. To use power, yes. So is that a question? How to make use of power?
Yes. Do we have to include like there's one
You have to
sim
include yes, you have to include the CMAT library. So to be able to use the power function, you say include within the brackets and CMAT. And then you are going to say, for instance, if I say, I want to raise something x to the power of 10. So I will say x, here give 10. I have typed it for you in the chat room. So if I want a to store x power 10, this is how to write it. And also you have to include the CMAT library in the include. So just like you have include IO stream, you will say include CMAT. And also if you, I think for the lab sheet, there are some questions related to storing the name, surname, address. So then if you can't use, if it doesn't allow you to use the string variable, then you can include the string library as well. So it all depends on your compiler. Any further question? So you have a reference guide for the CMAT library, which I'm going to post already in the chat room here. So please go through this. This gives you the full reference in terms of what are the different functions and also examples how to use them. So if you have to use, in some examples, you will see that you have to use sine, cosine, trigonometric functions. So this is giving you the different list of functions and how to use them. And once again, for using, if you have a question which requires you to input the angle, so the angle has to be transformed to radian before you can actually use it in your trigonometric functions in the CMAT library. Okay, so I have other, what's there? So in tutorial 1, there are questions concerning trace table. What are trace tables? How to do it? Okay, so once again, you are already ahead. You are working on tutorial 1, which comes maybe after week 5. So you can go and check. That's probably lecture, I don't remember. So maybe lecture 4 or 5, where we are talking about trace tables. So trace tables is basically when you're dry running your program and you're trying to see what is you're predicting the output of your program. So you would be having one colon for each variable and a last colon for output. So go and check the lecture notes. It should be there somewhere, but honestly, I don't remember in which lecture it is. Any further question?
Can I ask you a question in lecture 1?
Yeah, sure.
There is a slide. What is a computer? There was a diagram there.
Yes.
Can you show it on the? Can you share screen and show it, please? I wanna check something.
Okay, just give me a second. Let me open it first. Do you have a class after this?
Yes, right. At 2 p.m.
Yes.
Yes.
Okay, so my class is over. I don't want you to be delayed for the other classes. So we can, if it's a quick question, I'll take it quickly. Otherwise, we can have a look at it next week. So where is it?
I think
You know which slide it is? So it should be at the beginning, right?
yes, it should be at the beginning. I don't know the exact slide, but
It's this one.
yes. For the you see in there is input, output, and processing unit.
Yes.
For the input to go to the processing unit, shouldn't it be only one way? Why the processing unit has a double, like two-way arrow?
No, because it could be that you require further input. So the input is not just only at one time. So initially you could have some input, but then during your program execution, at some point you could be having other inputs which are going to come.
Oh.
You understand what I mean? So the processing unit will be using both the input and the output. And it might capture more input at some instances.
So the
I
processing
get the confusion. So your confusion is basically in terms of, okay, so when we are saying sending some input, it should be one way, sending the information to the processing unit.
yes.
Processing unit is not, okay, so I'm just trying, I didn't create this diagram. I'm just trying to interpret what they're trying to show here. So probably they want to say that, okay, at some point in time, you will require more input, but I do agree with you that yes, it could have been just one way. So the input is always sending to the processing unit, and the processing unit is having a two-way traffic with memory because it will be storing it there.
Okay, that's all. I was having confusion on that when I was doing revisions.
Okay. Okay, any further question? No? Okay, anyway, I'm not going to take any further questions. I don't want you to be delayed for the next lab. If you have any further questions, please, you can keep it for our session during our lab sessions on Wednesday. Okay? Donc, bon courage, bonne fin de semaine et on se voit mercredi.
Merci.
Bye-bye.
Madame.
Bye-bye.
Au revoir.
Bon appétit.
Au revoir.
Bye-bye.